Black holes are some of the most fascinating objects in the universe, even if we can't actually see them. They have the ability to warp space and time and to swallow anything that ventures too close, including light. But despite all the mystery surrounding them, scientists have learned a lot about these strange objects. Here's what we know about how black holes form. First, let's take a look at the two types of black holes, stellar and supermassive. Stellar black holes are relatively small, ranging in mass from a few times the mass of our Sun to around 100 times the mass of our Sun. On the other hand, supermassive black holes are millions or even billions of times more massive than our Sun. And while stellar black holes are relatively easy to come by, supermassive black holes are much rarer. So how do these two types of black holes differ in terms of how they form? Well, it turns out that the formation of both types of black holes is similar. In fact, the main difference is just the size. Stellar black holes, as the name suggests, are born out of the death of massive stars. When a star runs out of nuclear fuel, it can no longer produce the energy that counteracts the inward pull of gravity. Without this outward push, the star collapses under its own weight. And if the star is massive enough, this collapse continues until a region with an incredibly strong gravitational pull is formed so strong that not even light can escape, collapsing the core of the star into an infinitely dense point called a singularity. The boundary of this region is known as the event horizon, and the stellar black hole is born. This process also produces a tremendous amount of energy in the form of light and other radiation, which is emitted in all directions. This is known as a supernova, and it is one of the most energetic events in the universe. Supermassive black holes, on the other hand, may start their lives in a similar way. That is to say, the death of a very massive star could leave behind an object with sufficient mass for a black hole to form. However, this is unlikely to be the whole story. Instead, supermassive black holes are thought to form through a different process. According to this theory, they start out as small black holes that form in a similar way to stellar black holes, perhaps from the collapse of a massive gas cloud. However, rather than remaining small, these black holes go on a journey, merging with other black holes along the way. Over millions or even billions of years, these black holes can grow to millions or billions of times the mass of our Sun, forming the supermassive black holes that we see today. But what makes a black hole in the first place? What is it about these objects that gives them such immense power? Well, it comes down to their size and mass. You see, everything in the universe has a gravitational pull, and the strength of this pull depends on the mass of the object and how far away it is. The closer the object, the stronger the pull. For example, the Earth has a gravitational pull that keeps us firmly planted on its surface. But if the Earth were much more massive, its gravitational pull would be much stronger, and it could pull us in much closer. And this is exactly what happens with a black hole. Its gravitational pull is so strong that it pulls in anything that gets too close, including light. When something gets pulled into a black hole, it crosses the event horizon and disappears from view forever. Once something crosses the event horizon, there is no way out. Not even light can escape a black hole's gravitational pull. This is why black holes are black. They don't emit any light or other electromagnetic radiation that we can detect. We can only observe them indirectly by watching how they affect the things around them. The boundary of the region from which nothing can escape is known as the event horizon, and it is a defining feature of a black hole. The size of the event horizon is directly related to the mass of the black hole. The more massive the black hole, the larger the event horizon. In fact, the event horizon of a black hole is the only thing that we can actually observe. It is the boundary between the region from which light can escape and the region from which it cannot. But what happens to the stuff that falls into a black hole? Anything that falls into a black hole passes through its event horizon and enters a region known as the accretion disk. As it falls deeper into the black hole, the gravitational forces become stronger and stronger. Eventually, it reaches the singularity, a region of infinite density. What happens to the stuff that falls into a black hole is ultimately unknown, since nothing can escape from inside a black hole to tell us about it. However, we can observe the material in the accretion disk around a black hole, which emits tremendous amounts of energy in the form of light and other radiation. By studying this radiation, we can learn a lot about the black hole itself, including its mass and its spin. As we mentioned earlier, one way we can indirectly detect black holes is by observing how they affect the stars around them. Stars that orbit around a black hole are pulled in tighter by its gravity than they would be around an object of the same mass, but without a black hole. This is because the black hole's gravity is stronger than that of a regular object due to its high density. As a result, we can sometimes see stars orbiting around invisible objects in space and infer that these objects are black holes. In fact, astronomers have been able to study the orbits of stars around black holes in order to measure their masses. By measuring the mass of a black hole, we can also determine the size of its event horizon. This is done using the Schwarzschild radius formula, which relates the mass of a black hole to the size of its event horizon. The larger the mass of the black hole, the larger its event horizon. Astronomers have used this method to measure the mass and size of many black holes, including the supermassive black hole at the center of our Milky Way galaxy. We also know that black holes emit a type of radiation known as Hawking radiation. This radiation is named after Stephen Hawking, who predicted its existence in 1974. Hawking radiation is emitted at the event horizon of a black hole, and it has a thermal spectrum. This means that the radiation has a range of temperatures. The hotter the black hole, the more energetic the radiation. Black holes can lose mass through this radiation, and eventually they will completely evaporate. However, it is thought that this process takes place over a time scale of billions of years, so it is not something that we need to worry about anytime soon. While we may never be able to directly observe a black hole, the effects that they have on the universe are undeniable. From the stars that orbit around them to the radiation that they emit, black holes provide us with a window into some of the most extreme environments in the universe. By studying these objects, we can learn more about the fundamental laws of physics and the nature of reality itself. So what do you think? What are your thoughts on black holes? Let us know in the comments below. And don't forget to subscribe for more videos like this one. Thanks for watching.